panel, we will be discussing a couple of things to begin with. First, within the space sector, we have a lot of muddled lexicon. We talk about, as a licensed architect, I can say space architecture, very different definitions depending on who you're talking to. One thing I'd like to address up front is in public-facing capacities, we often are hearing about bases and settlements and colonies. And these words are used interchangeably, but they're really not interchangeable. So to begin, I'd like each of you to tell us what your vision is for the structure on the moon for our very first lunar communities.
Sure, I'm happy to kick that off. I think that fundamentally, when I look at these lunar communities and their early stages of today, I think mostly about economic frontier outposts. I think these economic frontier outposts will establish the infrastructure necessary, the communication layers, the resource layers, and of course I'm going to say the financial layers for trade, for promotion of activity between a diverse group of firms. I'm anti-monopoly and free market economist, so just have to make sure you understand that. And when we have many companies providing resources to each other, they'll be engaged in trade, they'll be engaged in commerce, and this is a self-licking ice cream cone. You have people buying goods from one company, selling goods to another, and there'll be a movement away from what we have now, which is a monopsony, where primarily it's governments providing the demand signals, right? So this is going to be the flip of that, where we have a diverse group of providers. And I think that's really key to a successful and sustainable community. It can't just be Uncle Sam and our allied partners funding everything. We really do have to have companies supporting each other, buying and selling from each other, and that's what I think would be the most important thing in a sustainable future lunar economy.
The way I envision a community on the moon in the mid to long term is predicated on the idea that there will be different stakeholders wanting to go to the moon. To me, we should envision a growing base with three constituencies mainly. Number one, science and exploration, where people will be there on the moon to really learn to know as much as we can about the moon. The second thing would be prospectors, people who are there to turn or look for resources and turn them into viable, economically viable, actual resources. And then the third major activity that I see going on the moon is tourism. And the way you would envision a base, and there are some examples on the Earth already for that, is a central spaceport with different communities really centered around this the spaceport, which is your key to accessing the moon and leaving it. And so I'm imagining a base that would have a sort of a research wing, a prospection and commerce development wing, and then a nice tourism resort, all sharing the same airport, so to speak, or spaceport. And the reason why you want to be clustered is because our very human presence there is going to be a critical factor for safety, efficiency, logistical ease, and there you go. I have more to say about this, but later.
Yeah, and not to be boring, but I agree with what both of you said, and I think I'll say that I think it moves in phases that sort of transition or blend into one another. Starts with Artemis Moon Base, primarily for science exploration. Expands into something more like an industrial park, where you've got ISRU, mining, data centers, and so forth, other industrial activities. And that'll grow into an increasingly diverse set of commercial activities. So you could envision maybe that third phase as a commercial complex. And then hopefully we go into like settlements, people living and working in space. And by the way, if you're interested in that, in kind of how that maps out, there's a great paper by one of the Lunar Development Cooperative Working Group members, Brent Sherwood, on exactly that, on these like phases that I encourage you to look up.
Good morning. Well, I'll answer the question from the other end, the market end. As of 3 to 5 months ago, the global economy has shifted gears. We're in an inflection. This is a new economic era. Very few of us realize that we're in the inflection, and it will become apparent and priced in towards the end of this year and into 27. The surface of the moon has become inexorably entwined with the economy of the Earth this year, right now. What we traditionally think about bases or settlements or outposts or what are we going to do on the moon is an irrelevant question. The question that it really should be asked is what is the driver for economic throughput on the moon? And that is going to change everything. And I believe we will have a 3 order of magnitude increase in space activity between now and 2040 than we currently envisage in our pre-inflection economy. So I see cities on the moon, starting off with NASA Ignition's excellent initiative, which is going to drive the prosperity and the development of cislunar infrastructure in ways we couldn't really imagine.
So jumping off of the economic conversation, which I think is a very valid point to today's topics, including funding, building, and governing sustainable lunar communities. George, because you are chief economist at Milky Way Economy, I want to get your breakdown of the monumental, almost abstract, it's so large question of funding here. So we're looking at, we know NASA's involved with the initial lunar base, but for sustainable long-term communities, who else is funding them? How are they funding them? Why are they funding them? Who, how, and why?
So I think if you'd asked me this question 2 or 3 years ago, I would have said that the future space economy and the Milky Way economy's numbers that it'll be hitting 4 trillion in the 2040s, very much in line with the 4x number of our colleague here, and then 10 trillion in the 2050s. And the way you get to that number has actually changed, and we have not put out revised numbers, just to be clear, but I've seen enough over the last year that it's probably time. And the reason for that is the hunger that we now have for data will demand data collection in new environments and in harsh environments. The things that we will be doing to great lengths to make sure that we're collecting that, whether it's the data on the performance of autonomous robots as they're building these structures, the data on the particulates, the data when we want to go from having a proven reserve to having a ready available resource, right? So when you think about the oil and gas industry, there's a difference between reserves and resources. One you can actually collect capital on, the other you cannot collect funding on. Once you have proven reserves, that opens up financial structures. These are known financial structures that, again, for example, the oil and gas industry use today. As you have proven reserves on the moon, you'll have very similar financial products used to then fund the activities of businesses to then go out and extract those. Those businesses will require autonomous robots. Those autonomous robots will be collecting thousands and thousands of points of brand new information that will then feed down into systems here on Earth. And the premium that we're paying for novel data, I think is going to drive more activity than we were previously thinking. It's AI. And if you didn't say it on the panel, then it couldn't be a panel here at Symposium this year, right? But I really do think we've mispriced that driver in earlier models. Of course, everyone's going to keep looking at the frontier of biotech. I think that, something I've said previously and published a report on, but I'll mention it again here because it's worth saying, is that you have to think about what's the next purple pill, right? What's the next shot that keeps us all skinny? And when that's done in space, I mean, obviously I don't take it. And when that's done in space, it's going to have a very awkward follow-on meeting for your competitors. Because let's just say, that breakthrough came out of Pfizer. I don't want to be the guy in the board meeting for Johnson & Johnson saying, well, we don't have a presence developing anything on a lab up there. I mean, it's a cycle where once one gets started as an anchor tenant, the others will have to follow. It's the same thing with data. We're going to have more people up there doing missions to collect this novel data. And this is going to expand the ecosystem much quicker from just an outpost to a city in timelines that we were not envisioning before, much quicker timelines. Yeah.
Michael, yeah, I'd love your thoughts on this.
Yeah, well, because, absolutely right. And I think that one thing that could help this quite a bit are what we have on Earth when we're trying to promote economic growth in a region that's either affected by conflict or a very poor region. We have developed these great tools like development finance institutions, right? These are entities like the World Bank, or the US has the Development Finance Corporation, there's the African Development Bank, many of these. What these institutions are able to do is fund infrastructure projects that are too expensive or too high risk or don't generate a profit in a short enough time frame for ordinary commercial infrastructure investors to take part. They also finance infrastructure that wouldn't be possible for a government agency to pay for out of its existing budget. Instead, they make an investment through a loan or loan guarantee, which lowers the risk for infrastructure projects to enable commercial investors to join. And those are designed to generate a profit over sometimes 30, 40, 50 years. I think these are the types of models that we need to begin implementing if we're going to make this transition from just sort of science and exploration type kind of limited government missions to something like that's a more complex economy.
Jim, just a brief response. I'd love to hear, especially with the Lunar Cities Initiative, what your thoughts are on that funding question. And I would love to get to building, though, so we'll keep it brief here.
So on the economics, I think George is spot on and ahead of the game. The drive for data is insatiable. AI supercompute is 3 orders of magnitude token utilization on inference with agentic workflow than with application utilization. The only reason we got the lights on today is only a fraction of a % of people are using that level of power right now. We are in the insights of a seismic tsunami, to mix my analogies, of a demand curve of power and inference over the next 3 to 5 years that has $7 to $10 trillion of capex priced in for terrestrial build. It's not all going to go terrestrial. We're going to take that to the moon.
So taking it to the moon, Pascale, I've been dying to ask you about building. We're looking at one of the most toxic, inhospitable environments known to humankind. How do we build a lunar community to survive and operate in this kind of condition? What's the plan for water, for lunar dust, for radiation?
Yeah, I mean, this is the constant that is going to be a prevailing concern for a long, long time, which is the fact that, we can build habitats, we can build an infrastructure, but nevertheless, the external environment will remain lethal probably for centuries, if not, for astronomical timescales. And the thing about living and working in an extreme environment is that you can get to the point where you have an indoor life that is quite isolated from what's happening on the outside. But if your purpose of being there is to actually explore the outside, to have mining activities or to have tourism going on, to have even data banks to manage, you're going to be faced with that cruel reality of the surface of the moon being lethal. Luckily, one of the key sources of harm on the moon is ionizing radiation from deep space. I love the idea of living on the moon and having habitats, but I see too many illustrations that somehow just show modules that are sitting there on the surface of the moon, as if you did not need to protect these from space radiation, which is a real issue. And the reason why on the space station, for example, we don't have to worry too much about that, of course, because even though we're outside the Earth's atmosphere, which provides radiation protection for us, the space station is still within the Earth's magnetic field, which of course protects it from lethal ionizing radiation. But on the moon, you are essentially, most of the time, outside the Earth's magnetic field. You only enter it through the magnetotail a little bit, and then you keep going. And so you're faced with the brunt of deep space radiation all the time. Regolith is probably a key resource for you to protect yourself on the moon from radiation. And we often see regolith piled over habitats in some illustration, which is already a good step forward. It's addressing ionizing radiation. But the real solution is really sandbagging. And it's as basic and trivial as that. The military do that to, of course, hide shelters in the field, but also to protect them. Sandbagging is what we use commonly on the Earth to protect ourselves from flooding. Sandbagging regolith is going to be a big business because you are going to want to essentially bury your surface habitats on the sandbag. And the reason why sandbags is such a good solution is because it's movable. When you have a habitat that's just buried under a pile of regolith, you're dealing with a big mess every time you want to reconfigure your base. But with sandbags, as a pragmatic solution, you can have robots basically move the bags, and you move your module, and then you repile them on. So we're going to have to learn how to survive on the moon with solutions that sometimes are pretty simple in their basic formulation.
If I could jump off that,
please.
I just want to jump off. So it occurs to me that something we haven't talked about that needs to be said, and it relates to this because I think back to my days as a Marine filling sandbags. And it's a very energetic process, let's put it that way. And since we're not going to have people filling these sandbags in suits, all of the energy required will be coming out of our machines. And so we have to think about the infrastructure being very energy intensive. And so we're talking about solar, we're talking about fission, we're talking, nuclear is going to be on the moon, folks. Like, this is the only way we have enough energy to get these hard tasks done. And so as we talk about the infrastructure, let's make sure we're double talking about energy and the costs of energy.
Yeah, well, power's everything.
Yeah, if you don't have power, you don't have civilization. Yeah.
So in terms of, you mentioned robots, we've talked about robots a couple of times, it's going to be a theme throughout the conversation. What, in your opinion, is the ideal ratio in a sustainable lunar community of autonomous robots to humans?
100 to 1.
Robots to humans?
Yes.
I think what we consider a robot today or in science fiction is probably going to make the estimate hard. I think that, what really separates this from a robot, right? What separates my wearable from a robot? Our definition is we're looking at, is the Terminator walking around the moon doing something?
It's assuming mobility.
Yeah, it's
Let's define robot as a
device.
mobile system. Otherwise, we're talking about tens of thousands per person.
Right.
Good point, George.
Yeah, so if depending on how you're defining it, it could be much, much larger.
So we also, Pascale, you touched on regolith and sandbagging and various different ways we're able to protect ourselves. In the panel's opinion, where are we building a lunar community? Is it on the surface of the moon? Geographically, where on the moon? Is it subterranean?
If I may, this is probably the most important question that remains unaddressed properly. I'm so happy that Artemis has segued to a moon base, because the way we were doing Artemis was essentially a repeat of Apollo, sort of a scenario where you have sortie missions. You go to a different place each time, and you really don't build up an infrastructure anywhere ultimately. You have remains and leftovers, but that's not an infrastructure. And the problem with that, of course, is that it's not an effective way. It's nice for scientists sometimes to think that way, because that's sort of treating the moon like a science buffet. You have a little bit taste of this, you go there next time, you eat some of this. But from an exploration strategy standpoint, it's a big dead end. And so a big victory here has been scored with NASA affirming, and all our international partners, that having a base on the moon is a good idea. So this is great. But the second most important thing about the base, because that's going to drive everything else that you do to make it sustainable and expandable, is, well, there are three key things: location, location, location. Not all places on the moon are the same. We have a fixation right now on the lunar south polar region, mainly based on the promise of lunar water ice being extractable and becoming economically viable. But there's still a huge question mark on that from a scientific standpoint. Just to give you some specific numbers, we have mapped one of the most reliable maps that we have for now of hydrogen, and therefore presumably water ice. The south pole of the moon has hydrogen at a level of 0.5 weight percent, meaning that if you extract 1 metric ton of regolith, 5 kilos of that if you're 100% efficient in extracting it, is water, 5 kilos. To fill a single Starship, if we went Starship, and let's assume that it's using cryogenics, so hydrogen and oxygen, which it doesn't, it uses methane and oxygen, you would have to excavate an area down to 1 meter, which is where the hydrogen signature comes from, an area of 26 football fields to fill one Starship if you're 100% efficient in extracting the water ice. So I'm not sure, as a scientist, whether the water ice at the South Pole of the Moon will just remain a scientific curiosity forever. And I think that predicating all our assets and the complexity of building a base, let alone operating in the South Polar region, if that's such a good idea to do that now. So I would recommend that we set up a base at an off-polar site within easy access to the South Polar regions where we want to continue exploring, especially with robots, but that we not trap and constrain all the rest of our human activities on the moon, including exploring the rest of the moon, by being in a location that's really possibly the worst place to set up an exploration base if you are interested in the rest of the moon.
Jim, I'd love to hear your response.
Well, I think these are all very valid comments. If I may, I'd like to just queue up a short video, and then I'll explain the value proposition. So that was a sequence intro to Stellar World and Lunar Cities. This is a multi-trillion-dollar, 30-year endeavor that builds a city of 10,000 people by 2050 on the lunar surface, 50 to 100 meters underground at the highest undulation. This will require millions of tons of displacement and excavation, millions of tons of throughput in lunar forges for manufacturing of civil engineering materials, lunacretes, metals and alloys. We're organizing supply chains of carbonaceous asteroids into lunar orbit for carbon and nitrogen, for plastics and agriculture. We're addressing every piece of the problem for extending human civilization out beyond Earth's domain. Now, why is this not fantasy, and why am I on the stage talking like this? 6 months ago, if we raised this value proposition, it would have been deemed crazy, and you would all been right. Today, I've been raising this value proposition. This week, we launched the program at the press conference, and most people will think I'm crazy, and they're wrong. The economy has changed. The world has changed. And soon it will be priced in. We will be building underground. We will be developing the expertise to do that autonomously and robotically, not just off-world, my company that undertakes and builds robots for terrestrial underground mining, but a supply chain of hundreds of companies over thousands of contracts that the Transplanetary Group underneath Stellar World is organizing now. We're distributing contracts across launch, transportation, power, surface operations, habitats, etc. So the key about this is mobilization. It's about moving fast. There is a geopolitical play as well, because there are first mover advantages in an economically competitive world, shall we call it. And it's important that we maintain open governance and standards for a movement of liberty as we move out into the solar system. And the final point I'll make about this is that this is not a government push. There are zero government dollars involved or required. This is not requiring space dollars either. As of this week, the lunar surface became a continent-sized expansion to Earth's economy. All of our commercial space assets that are Earth-facing are all serving end users, which all happen to be on Earth. The moon now serves end users, the surface of the moon, because of the absolute need of AI superfactories that cannot be built on Earth. We have trillions of dollars of asset development needed, and there are soft and hard limits emerging of building these in sovereign territories on Earth. The moon is the answer. It is a stable environment. There are no regulatory impediments. There are thousands of challenges technically and engineeringly that we need to undertake. We'll need hundreds of gigawatts of power, but we'll make that happen. We'll dismiss the risks over a few $100 billion, and then the value proposition will be 10x the build of data centers on Earth within 10 years from now.
I think I'd like to give the panel a chance to respond to that.
Well, one of the things I'd say right away is that when you look at a city, there's good reasons that they exist. It's not just because we like having friends and family close to each other. It's because as a finance guy or an economics professor, I'll tell you, you get economic agglomerations, which is probably something you had to test a long time ago in Econ 101. But an economic agglomeration occurs, and one of the best examples that most people are familiar with is what happens in Silicon Valley. You have a large number of people and businesses all working together, and because of their connectivity and because of their proximity, more economic growth happens than if they were spread apart. And so when you're talking about a city concept, you're picking up those economic advantages. And so when you look at a world economy of 120 trillion-ish, depending on whose numbers you like to use, and then you think about a space economy with a lunar economy dominating it that can get to the 10 trillion range, that is a meaningful percentage of Earth activities. You have 2 continents that do more than that. The rest of them do not. So it is a whole new continent worth of economic activity and an economic frontier.
And just on that point, since 1990, with a global GDP of 22 trillion and 125 trillion slated for today, with inflation, accounting for inflation, that's a 3x increase in global GDP. 5x by the numbers, but 3x accounting for inflation. With the agentic inference emerging right now, we're not even including robotics and then quantum computing and how we can maybe 1,000x our productivity as a civilization. I think we're looking at a 5 to 10x GDP over the next 30 years, approaching a quadrillion-dollar global economy. Yep. The big question is, what will be the distribution of that economy? What will be the equanimity of the benefits of that economy? How will we bring up the remaining billions of people to a standard of living of prosperity, opportunity, education, health, and security? That is a responsibility of those that have the means and the power to do that. How do we make that a fairer and more equitable world? It's by creating value and abundance and opening up the solar system to unlimited energy and an infinite reef of resources on the moon and the asteroid belt and the near-Earth asteroids. And that's how you change the prospects of a generation from a closed economy to an economy of abundance for the future.
Okay, so on that note, we're talking about communities, about cities now. When will we actually, as humans, be well enough adjusted to the moon to transition from lunar building to lunar civilization? Or, and Jim, I think I know your answer to this, but perhaps to the rest of the panel, is that not going to be in the future? Are we just using the moon as an outpost for us to, a way station for us to get from Earth to Mars and beyond?
I'm not Jim. Who's Jim?
No, by all means, yeah.
Well,
that's my cue to shut up.
Yeah. I mean, it's nice to have forward-looking dreams, and nothing happens, as you know, without that powering our minds and our ambitions. But at the same time, if anything teaches you that, I dabble, I do quite a bit of work in the polar regions of the Earth, in the Antarctic and the Arctic, and you are faced very quickly with the reality of the environment in which you work. You can't will the environment or submit it to your will. You really have to learn how to adapt to it. And I think we're going to be we're facing quite an adaptation period here before we are at the stage where we are really seriously building a city on the moon. So I share the vision of Jim. I don't share the time scale on which it's going to happen. But that's definitely open for debate, and it's a matter of priorities in our society and how we do things. What I would like to say is, you know, I have been thinking of a lunar base as basically the first step towards a growing presence, a permanent presence of humans on the moon. There are precedents, of course. The Antarctic is often brought up as an analog. The Arctic as well has its analogs. And again, if you look at those places, we were talking about financing earlier, who are the customers of these remote settlements and outposts? By the way, settlement, the way I define a settlement is you know you have a settlement when you have a zip code, okay, a postal code. That's when there's enough people living somewhere that you don't actually remember their names anymore. It's not like an expedition. You actually have a larger community. But if you look at the Antarctic and the Arctic, taxpayer dollars, in other words, government funding remains essential. And I think that will be one of the key ways of financing this is basically for nations to see that it's in their strategic interest to have a presence in the Antarctic, in the Arctic, or on the moon. And so our very presence, for example, in Antarctica is not to fund science. Science is what dominates our activity there, but the very reason why we need to be there is completely strategic, it's geopolitical, and that's why the NSF has a budget of about $2 billion a year to run the Antarctic program. So similarly, I think that governments will want us to be on the moon, each nation that is sort of a spacefaring aspiring nation to be on the moon because it's very important to be there. Now, that's what's going to fund the science, the exploration. And of course, the commercial partners will have their own shareholders wanting to finance exploration on the moon. And of course, that's with the prospect of being able to derive resources or manage data banks and derive resources from that. The third component that I was mentioning earlier is tourism. And tourism really should not be poo-pooed because we already see that in low Earth orbit. Tourism is a contender. It's a factor. It's one of the most fast returning commercial activities in space today. And I think the moon will attract a lot of tourism, either people who can really afford it or people who are very lucky, who win lotteries to go to the moon. And I can see how a resort on the moon would be amazing. I'm working on a paper with a student where we're talking about water sports on the moon. And you have to imagine a pressurized Olympic-sized swimming pool where you have diving boards where, I usually stay away from the highest diving board, but on the moon, I would not hesitate in 1/6 Earth gravity to jump into the water from the highest diving board. The point is there will be many interesting things that you can do on the moon that will be very attractive to tourism, very unique, very special, and along with tourism, the entertainment industry, et cetera.
And Pascale, just to contextualize very briefly, $2 billion NSF budget, $18, $20, $25 billion NASA budget, $7 trillion CapEx expenditure to 2030 for terrestrial supercomputing AI data centers. Anchor that context and anchor the paradigm shift that many of us don't see yet, but is the light at this end of the tunnel is not a train. It is an absolute opening up of the solar system economy.
Yeah, and again, it's throwing money doesn't solve all your doesn't solve all your problems. And
it solves enough of them to mobilize.
Absolutely, and I'm glad this is happening. All I'm saying is that it will take more than by 2050 to have, what did you say, 10,000 people on the moon?
This is a variable.
And I'll add, one of the most important discoveries in economics over the last, say, 30, 40 years is that the number one factor, number one underlying cause for economic growth, whether that's on Earth or in the future in space on the moon, are institutions. And institutions is kind of a technical word in economic terms, but it basically means rules. It's the rules of the game in a society, as Douglas North said. So this is why North Korea is different from South Korea. Why, you can draw out all of these sort of comparisons. If we can lay down kind of the fundamental rules that guide behavior, that incentivize different types of behavior, that will be the #1 factor in whether the moon sees widespread development, whether we see lots of activity, or on Mars or wherever, or not. So all of this is sort of another way of saying governance is very important.
And that's actually what I'd like to follow up with you on. At what point does governance start on the moon, and what does it look like? What are its priorities?
Well, it's already started, actually. I mean, since the 1960s, we've had governance of space, including through like the Outer Space Treaty, very important thing. The key move that we will need to make within our generation is moving beyond the traditional paradigms that we've relied on, which mainly include, we used to have, we have international treaties. Increasingly, we're relying on these sort of intergovernmental agreements that are almost sometimes like handshakes, not binding. These lay out really important high-level principles. They're very important as sort of as a foundation for building what we need for space. But oftentimes they are not enforceable, or very difficult to enforce, sometimes not legally binding. If we're going to move beyond the current kind of uses of space into something that we've got a diverse range of commercial space companies with governments from around the world, we need to begin building more effective structures for doing things like coordinating the use of scarce and allocating scarce resources. For instance, lunar orbits, which may get very crowded very quickly, especially if they're not allocated efficiently. Spectrum. How we deal with plume surface interaction, where with landings and launches potentially causing damage to other assets in the surrounding area. Do we develop structures that require compensation for people if you've harmed another party, or requirements to use landing pads with protective berms in certain areas? These are the types of mechanisms or institutions that will determine whether we can develop a real economy on the moon. The project that I have been leading, along with several people in the LDC working group and others, is the Lunar Development Cooperative, which basically addresses those two issues. It's both how do we build the next layer of institutions and making them enforceable and effective across borders that are built upon the Artemis Accords and other in the Outer Space Treaty and so forth. And how do we make sure that we're able to provide adequate financing for the infrastructure that'll be necessary for a lunar economy?
And just real quick though, but fundamentally with these structures and these institutions, what we need to remember to think about, because it affects our incentives and our risks. So if we have our incentives right, we'll have business activity. If we have our risks properly hedged or articulated, we'll have businesses making rational, free decisions.
Lightning round, one sentence. What's the most important thing that we haven't discussed yet today that's critical to the success of sustainable lunar communities?
End users.
Governance. We've talked about that.
NASA and all stakeholders, international partners, commercial stakeholders, should convene major workshops and conferences to decide to re-examine and rethink exactly where we want to put this base on the moon.
Space Force and Space Marines.
Thank you so much.
Good job.